Hey everyone, welcome back to the Basic Aeronautical Knowledge series. Today we're talking about speeds in aviation, speed units we use, why pilots use different units, and what you need to know for your flight training. We will discuss knots, indicated true and ground speeds throughout this video. Let's get into it. What is a knot? A knot is a unit of speed used in aviation. It measures how fast something is moving through the air. 1 knot is equal to 1 nautical mile per hour. When we talk about speed in aviation, we refer to 4 main types. Indicated airspeed. This is the speed shown on the aircraft's airspeed indicator. Calibrated airspeed. This is indicated airspeed with corrections for instrument and position errors. True airspeed. This is the actual speed of the aircraft through the air, adjusted for altitude and temperature. Ground speed. This is how fast the aircraft is moving over the ground, which changes depending on wind conditions. Understanding these different types of speed is essential for safe and efficient flying. In this video, we'll go deeper into each one. Indicated airspeed is the speed shown on the aircraft's airspeed indicator. This reading comes directly from the aircraft's pitot-static system and is not corrected for any instrument or position errors. So what is indicated airspeed used for? First, it is essential for aircraft performance and operating limitations. Many critical speeds, such as stall speeds and maneuvering speeds, are given in terms of indicated airspeed because it directly reflects the aerodynamic forces acting on the aircraft. Second, indicated airspeed is what the aircraft feels. It determines how much airflow is moving over the wings and control surfaces, which directly affects lift and control effectiveness. However, indicated airspeed does not always represent the aircraft's actual speed through the air. At higher altitudes, or when instrument errors occur, adjustments need to be made to get a more accurate measurement, which we will cover in the next section. Indicated airspeed is the speed a pilot sees on the instrument panel and is crucial for safe flight operations. Calibrated airspeed is indicated airspeed that has been corrected for instrument and position errors. These errors occur due to the way air flows around the aircraft and the sensors used to measure speed. At lower speeds and high angles of attack, these errors become more noticeable. As a result, calibrated airspeed provides a more accurate measurement of the aircraft's actual speed through the air. Calibrated airspeed is commonly used in aircraft performance charts and manuals. It helps pilots determine critical speeds, such as stall speed and takeoff performance, more accurately. Simply put, calibrated airspeed is indicated airspeed with corrections applied, making it more precise for calculations and flight planning. As you can see in the image of this example aircraft, the manufacturer has listed both the KIAS, which is knots indicated airspeed, and the KCAS, which is the knots calibrated airspeed. And you can see that there are slight differences in the speeds listed. Next, we will explore true airspeed and how it changes with altitude. True airspeed is the actual speed of the aircraft as it moves through the air. It is calibrated airspeed that has been corrected for altitude and air density. Why is true airspeed important? At higher altitudes, the air is less dense. This means an aircraft must travel faster to generate the same amount of lift as it would at lower altitudes. As a result, true airspeed increases with altitude. True airspeed is an essential factor in flight planning and navigation. It helps pilots calculate how long a flight will take and ensures accurate performance calculations. For example, an aircraft flying at 10,000 feet with a calibrated airspeed of 130 knots might actually have a true airspeed of 145 knots due to the thinner air. In summary, as altitude increases, true airspeed also increases. In the next section, we'll discuss ground speed and how wind affects an aircraft's actual speed over the ground. Ground speed is the aircraft's actual speed over the ground. It is true airspeed corrected for wind conditions. Why is ground speed important? First, it determines the actual time it will take to reach a destination. Unlike indicated or true airspeed, ground speed accounts for external factors like wind, which can either slow the aircraft down or speed it up. A headwind, which is wind blowing against the aircraft, will reduce ground speed. A tailwind, which is wind blowing in the same direction as the aircraft, will increase ground speed. Ground speed is a key factor in fuel burn, navigation, and arrival times. Pilots must consider ground speed when planning flights to ensure they have enough fuel and to estimate when they will reach their destination. Thanks for watching this episode of the BAK series. If you're just starting your aviation journey, make sure you subscribe so you don't miss out on more essential lessons to help you ace your flight training, and check out teamaviation.com.au for more resources. Hit that like button if you found this useful and leave a comment below with what you want to learn next. See you in the next video.